Now, what is thermodynamics? Thermodynamics is the study of change of a system through work and heat. Now, what are the two things you need to underline? The first thing I said is energy. The second one was what? Heat. And the third one was what? Work. Now, in this course, your energy, the symbol is what? E. While your heat, the symbol is Q. And for work, your symbol is what? W. So if you can remember these three things, then you know what thermodynamics is all about. When we talk about thermodynamics, we are basically talking about the interaction between what? The system and the environment. Now take this down. Terminologies in thermodynamics. Basically, we have three terminologies or three things we consider while taking this course. So you can take that down to be what? Terminologies of thermodynamics. I told you the first one is what? The first one is your system. Now the second one is what we call the surrounding. Now, if you are not hearing surrounding in this course, as the course goes on, you'll be hearing environment. So you can call it surrounding or what? You can call it surrounding or what? Environment. Why the last one? I told you there are three. The last one is called the boundary. So the last one is called what? The boundary. Now let's use an illustration to define our parameters here. Let's take Bola to be this. This is Bola. Now Bola is standing inside a planet called Pluto. Let's say this planet called Pluto. We are using this as an instance. Now the first one was what? System. From this illustration, what is our system? Our system here is what? Our system is what? Bola is our system. Now you ask yourself, what is now the system? The system is the part set aside for what? Study. The system is the part set aside for study. So Bola is the part which we want to study. So Bola is our what? Our system. Now the second one is what we call the surrounding or what? Environment. Now what is the surrounding and what is the environment? In our illustration, Bola, we know Bola to be what? Our system. Now, the remaining part of this planet, which is Pluto, is what we call our surrounding. And I told you, if you are not seeing surrounding, then we'll be seeing what? Environment. So you can take this down. The surrounding or the environment is the remaining part of the universe set aside for study. Now the last thing which we have to consider is what? Our boundary. Now what is the boundary? The boundary is the delineated part. When I mean delineated part, is the enclosed part. So this is our what? Our boundary. So boundary is that enclosed part for study. Now take this down. Types of system. Basically, in this course, we'll be talking about three types of system. Types of what? System. We have different types of system, but in this course, our focus will only be on three. Now, the first one is what we call the open system. The first one is what? Open system. The second one is what we call the closed system. And the third one is what we call the isolated system. Now, underline the first one, open system. Now, your open system is that system that allows energy transfer and mass transfer. While your closed system, it is that system that allows only energy transfer, but not what? Mass transfer. Then the last one is what we call the isolated system. And the isolated system is a system that does not allow both energy transfer and mass transfer. Now, your open system allows what? Energy transfer and mass transfer. Now, what is energy transfer? Now, your energy transfer is the what? It is the heat and work. This is the energy transfer. So if you are not seeing energy transfer, you might be seeing heat and work. So if you are asked any system that allows heat and work interaction with mass transfer, what is that system? That system is simply what? An open system. But what if the system allows only heat and work without mass? That system is called what? A closed system. But the isolated system, it does not allow both the heat and work and what? Mass transfer. The next thing we'll talk about is properties in thermodynamics. Basically, we have two types of properties in thermodynamics. Now, in thermodynamics, we recognize only two properties. They are well known in thermodynamics in this course. Two properties are well known. The first one is what we call the extensive property, and the second one is the intensive property. So the first one is what we call the extensive property, while the second one is what we call the intensive property. Now let's talk about the first one, which is the extensive property. What is the extensive property? Now in thermodynamics, the extensive properties, they are those properties that what? They depend on the mass of the system and the subsystem. So if you are not hearing mass system, you'll be hearing what? Subsystem. So any property that depends on the mass of a particular system is what we call the extensive property. Now, the intensive property is just the opposite of what? The extensive property. They are those properties that do not depend on the mass of a system. Now, let's take an example. We've talked about what? The extensive properties. And you said the extensive property, they depend on what? They depend on the mass of a system. Now, what are the examples of extensive property? Any property that depends on the mass of the system is an extensive property. Now, let's take an example. Now, an example of an extensive property is volume. E.g., volume. Somebody will ask, why is volume an extensive property? Now, yes, volume is an extensive property because the mass of a particular system increase, the volume will what? Increase. Now, let's take an instance. We said we have a bucket of water. Now, this bucket of water is filled up, while we have another half bucket of water here. This is the full and this is the half. When you change anything in that system, it will change. Now look at these two systems. Let's say this bucket of water, these two waters, they were fetched from a well. Both of them. Now we see that we poured the full one into the half one. This one became what? Full. This one is now what? Half. There is an increase in volume. So volume is an extensive property because that is affecting the volume. So volume is an extensive property. Now, what about the temperature? Let's say the temperature of these two waters, they are at 0 degrees Celsius. Now you pour this one inside this one. Is the temperature increasing? The temperature is not increasing. Whether you increase this half to a full bucket, the temperature remains constant. So temperature is an intensive property. So the next one we have what? Intensive property. Now, an intensive property, they do not depend on the mass of the system. So the intensive property do not depend on the what? Mass of the system. So parameters will be given to you and they will tell you to classify those parameters, whether they are extensive or what? Intensive. You can now write this down. We can convert extensive property to intensive property by dividing by mass. Now I told you to convert what? Extensive property to intensive property. What do? We divide by mass. Now, the next thing we are talking about is to convert extensive to intensive. Now to convert extensive properties to intensive property, we divide them by mass. Now let's take the first examples that we took for extensive property. And we said volume is what? An extensive property. Now, if volume is an extensive property and we want to convert volume from extensive to intensive, what do? We divide volume by mass. Now, when you divide volume by mass and you want to get an intensive property, then that property is said to be what? A specific intensive property, because you have divided it by what? Mass. So to divide, let's take the first one. The first example was volume. And volume is big V. And we are divided by mass. Abi? So this is what? Mass. Now if you divide volume by mass, we'll have what? M cube over kilogram. Which this is what? V. And we said when we divide volume by mass to convert to intensive, it will become what? Specific intensive property. Which volume here will be represented as small v. So small v is what? Specific volume. So we've converted what? An extensive property to what? Intensive property. What do? We divided it by what? Mass. Now take this. Note, extensive property are always written in capital letter, while intensive property are written in what? Small letter. So for an extensive property, how do you know a property is an extensive? An extensive property, when you see the property to be what? A capital letter, it is what? It is an extensive. But when that property is what? A small letter, it is what? Intensive. Now let's take another example. Energy. Energy is an extensive property. But if you want to convert the energy to be what? Intensive property, what do? We divide it by mass. So it will be what? For energy, big E divided by kilogram. Note, this your kilogram is the unit for mass. So this is what? This is energy over mass. Abi? Energy over what? Mass. Now if you do this, you have what? Small e, which is specific what? Energy. So this your small e is what? Specific energy. And what is the unit? Now the unit, it depends on what you did. So for you to get the unit, you know that energy, the unit of energy is what? Energy is measured in joules. And mass is measured in what? Kilogram. So what is the unit for specific energy? It will now be what? Unit per kilogram. So small e will be equal to what? Joules per what? Kilogram. Another example, which is heat. What is heat? Heat is an extensive property. So how do we convert this extensive to intensive? We divide by what? Mass. So if we divide by mass, it will now be what? Heat over what? Mass, which is equal to BQ over kilogram. Now, if we do this, what is now the specific heat? The specific heat will now be what? Small q. Because you've converted it from extensive to intensive by what? Dividing by mass. So if you do that, your big Q will now turn to what? Small q, which is specific heat. And specific heat is equal to, what's the unit for heat? Joules. And what's the unit for mass? Kilogram. So your unit will be joules per kilogram. So they will give you some parameters and they will tell you to get the specific intensive property of those parameters. Now for you to get them, what do? You divide by mass.